Okay, ladies and gentlemen, we're going to be talking about a couple concepts in graphing. They're called extrema and average rate of change. Now, if I were to take a simple graph like this, and I have something as follows. If I have this graph, I have a number of key points on this graph. This point here, here, and here are all called maxes or maximums. Okay, now of the three maximums, two of them would be considered relative maximums. And although this is also a relative max, this would also be considered an absolute max. Absolute max. Now, a maximum is simply the highest point. Now, the absolute max is the highest point on the whole graph. Relative maxes are highest points in their given area. Now, it works the same way. I have a relative min, so 1, 2, that's a min, that's a min. Those are both relative mins. This point over here, because it is a point and stops, is also a min. But because it is the lowest point, you'd be tempted to think maybe it's an absolute min. But unlike the maxes, where no part of the graph ever goes higher than this point here, this is still just a relative min, or local min if you wish, local or relative. This goes down, 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 down. So there is part of the graph that goes lower than this. Now, for this purposes, we have absolute max or global max, relative max, relative max, relative min, relative min, relative min. This, by the way, is also an end point because it is the end of the graph. We have a number of other points that are indicated and clear here as well, one of which is this point right here. All right. This point right here. There's another of them right here, and here, and here. And in this case, the graph between the two curves up. Here the graph curves up like a bowl. So if you have a shape like this, we call that concave up. On the other hand, we have this portion here, this portion here, and this portion here. Those are upside down, so we call that concave down. Now the point, these x's, between where we go from concave up to concave down are known as inflection points. Inflection points, because just as a voice goes up or a voice goes down, we're using inflection. So, by inflection points, concave down moves to concave up. Unfortunately, where these points are exactly, and really where the maxes or mins are, you won't be able to determine 100% until calculus. Now, another issue here is, as we read the graph from left to right, so let's move along the graph here. We have a little guy. He's walking along the graph this way from left to right. In this case, he has to go up. So this one would be increasing. This area here, he'd get to go down the hill a bit. This would be decreasing, followed by increasing, followed by decreasing, followed by increasing, followed by decreasing. So he would walk up, and then down, and then up, and then down, and then up, and then down. And so it's a series of increasing or decreasing, and that's not a problem. Now, the thing about it is, though, the slope of this line is going to be positive because it's going from one end to the other, it's going up. So we have a positive slope. Anywhere it's decreasing, we have a negative slope. Positive slope, negative slope, positive slope, negative slope. And it's those types of slopes that really become important when we start talking about the idea of the average rate of change. Now, we will talk about average rate of change here in just a little bit. Now, If I were to take something like the following, f of x equals x squared, we can find 4 points here on x squared, negative 2, 4, negative 1, 1, 1, 1, 2, comma 4. And in all of these cases, we can determine the slope at a given point. Well, this is on an upward area, so this slope would be considered positive. This point here is also on an upward slant, so it would be considered positive. These points here are on a downward slant, so they would be considered negative. This is on a downward slant, so it would be considered negative. The problem is, to find the slope of a line, m equals y2 minus y1 over x2 minus x1, then we need the slope formula. That requires 2 points. You cannot find the slope at just 1 point in pre-calculus. You'll have to wait until you get to calculus to do that. So the best we can do is, instead of 1 point and a slope through a single point, we can do slope through a pair of points. And by doing a slope through 2 points, it crosses twice. In a circle, it crosses twice. We call that a secant. So we're going to have the secant of our graph using 2 points. In this case, we're going to take 4 minus 1 over 2 minus 1. So the slope of this secant line is 3 over 1, a slope of positive 3. We'll come back to this idea for average rates of change in slope lines in a little bit.